Okay, so at the end of the last video, we were talking about waves interfering. And waves will interfere when they're trying to travel through the same medium at the same time. So we usually break the interference up into three different categories. There's what we call maximum constructive interference. And that happens when the two waves, the solid one and the dotted one, and I think you have this on your sheet if you printed it out, the solid one and the dotted one are passing through the same medium at the same time. And what we're going to get is a resultant wave. And that resultant wave will be the result of adding up the amplitudes. So over here they're both at 0. So the resultant will be at 0. Here the dotted one is trying to pull the medium up this high, and the solid one is trying to pull it up this high, but they're working together in the same direction, and so the resultant would be a point up here. Here they're both at 0. Here the dotted one is trying to pull it down, and the solid one is trying to pull it down. They're working together again. So you would add the amplitude. So when they're pulling in the same direction, you add the amplitudes up. And because these two waves are in phase, they're pulling in the same direction in all spots. So once you've added the amplitudes up and put your dots in to where the new amplitude would be, then you just connect the dots. So I've given you the two waves to add together. You have to draw the resultant in on your own paper. Okay? It's called maximum. It's the biggest wave you'll get when they're perfectly in phase. Constructive because it's building it up. Interference. It happens when the phase difference is 0 degrees, when they are right on top of each other in phase with each other, as opposed to the next one, which is maximum destructive interference. You'll see here that they're actually out of phase. We would say they're 180 degrees out of phase. They're shifted by 180 degrees from each other, right? If we moved it a half wavelength one way or the other, they would be back in phase. So here, the solid one is trying to pull the medium up, and the dotted one is trying to pull it down. And because I was trying to go for same amplitudes, but I'm not that talented. But in the end, they're going to cancel each other out. Here, the dotted one pulling up, the solid one down. They'll cancel each other out all the way along. And so the resultant will just be a flat line. It's actually called a nodal line. Remember we talked about a node was a point of 0 displacement. Well, a nodal line is a line of 0 displacement. Okay, so when they're 180 degrees out of phase, you get maximum destructive interference, a straight line. Oops, I didn't put the title on this one. The third one is intermediate degrees. Intermediate degrees of interference. In other words, they're not totally in phase and they're not totally out of phase. Intermediate degrees of interference. So if you look at the one I have drawn, it's actually 90 degrees out. It's a quarter of a wavelength out. Okay, and so what you have to do is add the amplitudes up all the way along. So here, the amplitude of the solid one is 0, and the amplitude of the dotted one is in the negative. 0 and negative will give you the negative. Here at this point, the dotted one is 0, and the solid one is up here, so the wave should be up here. Where they cross, they're both pulling in the same direction, and so the amplitude should be double. Here the solid one is 0, so the amplitude should be the dotted. Here the dotted one is 0, the amplitude should be the solid. Here they cross, it should be double. Here the solid one is 0, it should be the amplitude of the dotted one. Here the dotted one is 0, should be the amplitude of the solid one. Here they cross, should be twice as big. Here it's 0. My thing went off there a little, so it should be the dotted. Here the dotted is 0, so it should be the solid. Here they cross. Here the solid is 0. Okay, and if you were, once you've done all that, then you play dot to dot. Sound effects are not necessarily necessary, but makes it easier to hit the dots. And you too have to do this on your paper. Okay, so if you didn't print out those sheets, then you should draw the two that I started with. All right, and then it would keep going. Okay, so intermediate degrees of interference. Not perfectly aligned, not totally opposite, somewhere in between. And so what you do then is add up all the way along. Now, if I were to give you one of these on a test or an assignment, I would have it on a grid and you could count the blocks when you were adding so that you would it would be easier. Okay, this is one-dimensional along a string. We also can do it in two-dimensional. Okay, so in two-dimensional, imagine that we're playing with the water in your bathtub again. Okay, these are going to be your two fingers. And what we're going to do is we're going to move them up and down in unison, like this. And so every time you put them, let's say, down, it will be a trough, and every time you pull it up, it'll be a crest. So the green here will be the trough. I don't know if you can see that. And the pink will be the crest. I was trying to pick two colors that the other ones were green and blue, and I didn't think I couldn't tell them apart, so I was thinking you probably couldn't. I did the little lines so that I could kind of make my troughs and crests equal size. Okay, so what's going to happen as these waves spread out? They'll spread out on the other side too, but I'm not talented enough to draw it on both sides. What's going to happen as these waves spread out from your two fingers is that they're going to interfere with each other. Right? Oops, paper moved. It's never good when you're trying to draw. All right, that might be enough. It probably isn't, but we're going to do it. So wherever two pink cross each other, actually, let me do it with a different color. Whenever two pink cross each other, you're going to get maximum constructive interference. Two troughs crossing. Yeah, maybe I will do it in pink. Okay, I've changed my mind. Okay. So everywhere, can I make this bigger? There we go. Everywhere two pink cross, you're going to get a nice high crest. And everywhere two green cross, you're going to get a nice low trough. And if we were actually doing this in your bathtub, what you would see would be diamonds. I just need a few more. Ah! What happens when the paper moves when you're trying to draw? Okay, so you would see diamonds being formed. See the diamond of the green with the pink dot in the middle? So it would be jumping right out of the water. It's really cool. We could actually make them seem like they were standing still, diamonds. Okay, this is two-dimensional interference. Now, if we were to put, and we're going to run out of time, if we were to put a screen back here, and if these were two light sources, what we would see would be bright spots where the red and green are lining up. and dark spots in between, because look, the pink and green are crossing, a crest and a trough. It would be destructive interference.